Alright, in this video we're going to look at phase shifts for sine and cosine functions. A phase shift is the trigonometric version of horizontal shifts that we talked about earlier in the course. So they're just the periodic functions version of horizontal shifts. So for sine and cosine, as well as the other four that we'll talk about later, phase shifts are nothing more than horizontal shifts. With horizontal shifts, you add or subtract something inside the function. And with sine and cosine, we typically like to throw in period changes as well. So that's where you'll see the b here as well. So for sine and cosine functions, phase shifts are typically going to resemble the following: sine or cosine of bx minus c, or maybe sine or cosine of bx plus c. And again, the b out in front of x is a period change, but when you add or subtract inside parentheses for the function, that's going to mean a phase shift. So in the vertical shifts video, we didn't include parentheses around what we added or subtracted. So parentheses do actually matter for in terms of, are you moving up or down versus are you moving left or right. So to find the value of phase shifts, much like with horizontal shifts, just set what's inside the parentheses equal to 0 and solve. So if we set bx minus c equal to 0, and solve for x by adding c and dividing by b, then that'll tell us how far from the origin our graph is going to shift. So could be something like 30 degrees, 45 degrees, could be even something offset like 70 degrees, who knows. So positive answers for solving this equation for x means your graph is going to shift right that many degrees or that many radians. And negative answers mean your graph is going to shift to the left by that many degrees or that many radians. So again, just like with horizontal translations from transforming functions, positive answer is going to move it right, negative answer is going to shift it left when you set what's equal to 0. Set what's in parentheses equal to 0 and solve. Alright, so determine the phase shift for each of the following. Don't forget to indicate direction. So we're going to start with y equals sine of x minus 30 degrees. And notice the minus 30 is inside parentheses, which means we have a phase shift on our hands. So here's sine of x, and then here's sine of x minus 30 degrees. So notice we took... we had a maximum value here at 90 degrees for the red graph originally, and if we look at the blue graph, now it's at 120. So we had it at 90 originally. Now on the blue graph it's at 120, and that's a shift of 30 degrees to the right. So if we set x minus 30 in parentheses equal to 0 and solve, we get x equals 30 degrees. And that again is a 30-degree shift to the right, as we can see with the graph in red originally, and now the graph in blue. All right, next up, example B, we have y equals cosine of x plus 135 degrees. Notice again, the plus 135 is inside parentheses. So if we take a look, here's our cosine graph normally. And here's cosine of x plus 135 degrees. So notice where we had the top at 0 for originally. Now the top is 135 degrees, and that got moved to the left. So if we set x plus 135 equal to 0, we get x is negative 135 degrees, again indicating that our graph in green was shifted 135 degrees to the left to produce the graph in purple. So it's 135 degrees shift to the left. Next up, we have sine of 2x plus 90. So here we have a period change by multiplying x by 2, and we have a phase shift as well. However, this time since there is a coefficient for x, since there is a period change, our phase shift is not going to be 90 degrees. So let's again look at sine of x. Here's our sine of x graph, and here is our new graph. So notice again, we got a lot more waves in blue than we did originally in red, and they're offset. So we did have a little bit of a period change and a phase shift. So if we set 2x plus 90 equal to 0, solve for x by subtracting 90 from both sides. We get 2x equals negative 90. And then divide both sides by 2, we get negative 45 for x. So x is negative 45, means our graph was shifted 45 degrees to the left. So, and by a factor of 2 as well. Right. Next up, we have cosine of 3x minus 270. Again, so here's our cosine graph, and here is cosine of 3x minus 270. I don't want that to be the same color. So let me just change this real quick. Change it to black. There we go. Okay. So we have 3x minus 270. So we have a period change and a phase shift, but again, the phase shift is not 270 degrees. If we look at 3x minus 270 equals 0, add 270 to both sides, we get 3x equals 270. So we have a new value at x is 90. So originally we were at 0, 1. Now we're at 91. So it was a shift to the right 90 degrees. So we had that 90 degree shift. We also had the period change of 3. So that is the phase shift 90 degrees to the right for cosine 3x minus 270. All right, and then just kind of summarize a lot of what we talked about in the past few tutorial videos. If we put everything together, a sine bx minus c plus d, or a cosine bx minus c plus d, our amplitude is the absolute value of a. The period is 360 divided by b, or 2 pi divided by b if we're working in radians. So phase shift is c over b, and again, it's positive, it's moving right, negative, it's moving left. And then vertical shift is d units up or down, depending on whether it's positive or negative. So, all right, that about does it for this video.